Hello, year 11. As promised, we're going to pick up today's work from question 12, do some A and A star stuff. If this A and A star stuff, you just feel it's a little bit, maybe that's not why you're aiming, right? Maybe you're aiming to get those C's, those B's, maybe scrape those A's, then I would go forward in this video to the end of this section where I'll do some just random things with you, some random ideas, maybe even pick up a new paper and just see what's in there, okay? Give you some ideas to think about. But I did promise I'd pick up here now. I've had to export this into Word, and it hasn't exported perfectly. You can see there's gaps, right? For example, that's in X equals, I believe, and Y equals. So there'll be a few times when that happens. Here's the idea here, okay? This is what I called with my class the fishy question, okay? The proportional question. You wouldn't get this in numeracy, but you will in maths. Y is directly proportional to x cubed. If it's directly proportional, you write k times x cubed. However, what I am going to do is I am going to run a simultaneous question here if it was inversely proportional. Okay, now it doesn't have to be x cubed either. It could be just x, it could be x squared, it could be the square root of x. But if it's inversely, you'd put k divided by x cubed. So directly, k times the thing, inversely, k divided by the thing. Then you put in your numbers. Y equals 96 when x equals 4. Okay, sometimes people, when they substitute and put these things in brackets, that's okay, right? I didn't really like this one. I didn't like a lot about November. I've been saying that a lot today, haven't I? But 4 cubed is 64. All right, I wouldn't normally write k64. I'd probably write k 64k, but k times 64. The opposite of times in 64 is to divide. So much of this is to do with, being able to move things over and equals, knowing that pluses become minuses, the times become divided all the way through the paper. Whether you're solving, changing the sum of the formula, this kind of thing, so much, right? And I'd be looking at that going, how do I know that without a calculator? Right. Well, the best way to do a fraction, to work out what a divide is without the calculator, is to simplify the fraction and make it easier, right? So if you divide them, we could just keep halving and halving and halving, right? I'll speed that up a little bit because they're both in the 8 times table. I can see that. So that would become 12, and the bottom one would become 8 because they're both in the 8 times table. Actually, now I could half those again to 6 and 4, and I could half those again to 3 and 2. Okay. 3 divided by 2, that's far easier. Half of 3, that's 1.5. K is 1.5. Do not forget, though, I'm going back to November, seems a long time ago, that your final answer is this. Y equals, however, you've used the numbers they gave you to work out what K is. You know that K is 1.5 x cubed, and that's that. Now, I don't think these numbers particularly work for what I'm attempting to do here. No, they don't. But just to give you an idea, I'll do it anyway, right? In this one, you'd put the 96 there, and if it was inversely proportional, obviously you divide it, you're not times in by 4 cubed, you divide in by it. So it becomes 96 equals k divided by 64. And therefore, rather than a times becoming a divide like it did here, the divide here goes up to be a times. I am having no interest in working out 96 times 64, right? It would not be that hard. It's just because I wanted to show you. But look, let's say it's 6,100. It's not. So don't do, right? But let's just say that's that, right? You then, again, that would be your answer. But instead of K, you would write what you've worked K out to be, okay? But please ignore this. Ignore this side. This is the correct answer to this question, and this is the one we're going to use now in part B, which says use your answer, use your formula, use this, but put this value in instead of x. Well, we'll do y equals 1.5, and instead of x, you want me to put in 10 cubed, which I can do. X, all right, 10 cubed is 1,000, also 1.5 times 1,000, or 1,500. Yeah, don't mind it. This one is always a nightmare, where you start with the same formula, y equals 1.5 x cubed, but this time we're not substituting in x, we're substituting in y. We're putting the 12 there. Please don't worry about this one. Again, switch off, fast forward 20 seconds, whatever you want to do. The opposite of times in 1.5 is to divide by 1.5. That becomes 8. So x cubed is 8. And therefore, to find x, we'd need the cubed root of 8. So x would be 2. That is very, very, very tricky. Let's have a look at how the next question has come out when I've put this into Word. It's probably gone wrong again. There we are, a whole missing page. Let's assume this on the next page. Ah, there it is. Okay. Ladies and gentlemen, again, I'm talking A star. I'm not talking getting your C's, getting your B's out, right? There is always a question where you will have to solve by factorizing a quadratic, right? Sometimes that question has a part A, which is a show part. This is not the solve part. The solve will be coming up in part B. So there is a question where show this, then solve it. The solve is much more important than the show, because the show could be anything. Again, there are missing things. I know that one's in equals. I'm not sure if these missing things are pluses or minuses. I'll work it out in a minute, right? But it says the sum of the area of A and B. I'm going to do it up here, actually, because I can see the shapes then. The sum of the area of A and B is equal to the area of C. Well, let's write that as a formula. So the area of A is 9 times 1. That's 9. I can cope with that. This one is the length times the width, but you times that by both those things in the brackets. So it's 3x squared plus 3x. This one, oh my word. All this should go down in your workings out. Obviously, don't write this all up here, but I'm just doing it so you can see is the length times the width again, which is going to be foil or smiley face or whatever you use, x squared plus 4x plus 4x plus 16, or x squared plus 8x plus 16. Okay, we're told they're equal. So 3x squared plus 3x. This one, add this one is equal to this one. I'm going to run out of room. Brilliant. I'm struggling to keep it on the page. I'm just writing that. That's fine for now. Okay, right. Any quadratic needs to equal 0. So all of these things tend to come in a question like this, tend to come over this side, okay? So 3x squared already over here, but I'm bringing an x squared over. Take it away, it becomes 2x squared. Take the plus 8x away from the 3x, you get minus 5x. Take the, no, it's not 11. Take the 16 away from the 9, you get minus 7. And you've done the answer. You've shown it. Just do your best with that question. Try and expand brackets and make things equal and just see what you can get to, right? But at least I now know that that's a minus, and I've shown it. I've shown it. I've used your description to show it. I don't care about a show question. I care about the solve bit. And yet again, I've got a page gap before the solve bit. Okay. We know that they're minuses and that's equals now, right? The reason they have given you this is because not many people in Wales will get part A right. So they have to give you the equation, otherwise you've got nothing to solve, right? The algebraic method to solve one of these, which we call in maths a quadratic, is to factorize. And we talked about factorizing quadratics earlier, but this is a hard version. This is a hard version because there is a number there. Let me remind you earlier, again, please ignore this bubble. If somebody asked me to solve this, I would straight away go to those. Right? And I'm looking for two numbers that will times to make 30. Got 1 times 30, 3 times 10, 2 times 15, etc. But they need to add or take away to make plus 7. So the numbers are going to be 10 take away 3. 10. Those numbers will times to make 30. I should have written minus 30. I got that wrong, right? Because just rushing, right? Will times to make 30 or minus 30 in this case. But more importantly, when I do 10 take away 3, I get plus 7. That's it. And then you go on and solve it. And I'll show you how to do that in a minute, right? This is different because there's a 2 there. There's some extra steps. The first extra step is this. Instead of x in both brackets, you write 2x in both brackets. It doesn't quite make sense at the moment, right? Because actually 2x times 2x is 4x squared, but this method works. Sorry if you haven't seen this, if you're in a different class to mine. I know it's a bit late trying to learn it. See how you get on with it, right? We are still trying to times to make the end number, but you have to multiply that end number by 2 in this case, because there's a 2 before the x squared. So I'm looking for things that times to make 14. That's it, right? Which one of those pairs will also add or take away to make the middle number, which is -5? Well, the pair that will do that is this pair, but it's not 7 take away 2, which is +5. It's 2 take away 7, which is -5. So it's 2 and take away 7, plus 2 and take away 7. Okay, right. The final thing, for those who've never seen this before, and I'm really sorry, but it's going to be hard to pick this up. If you've got your different method, please use it, right? If you've got a different method, please use it. If like a tutor or another teacher has, just ignore what I'm doing here. But the final thing that I do in my method then is I look for common factors in each bracket and divide by it. So because both my numbers in this bracket are divisible by 2, I will. In this bracket, there's nothing that will go into 2, also to 7, so there's nothing to divide by. If I half this bracket, I get x plus 1. And I chose to, there's nothing I can divide that bracket by, so it's not changing. That is the factorized bit. That is the algebraic method they're talking about. In this case, the algebraic method is factorizing. The solve bit is either x plus 1 equals 0. Either this bracket needs to be equal to 0 or this bracket equals 0. To make this bracket 0, the plus 1 would move over and be minus 1. To make this bracket 0, the minus 7 would move over to be plus 7. But I don't want 2x equals 7. I want x equals 7. And because it's times 2, on that side it's divided by 2. In this case, if I go back here, you would have x equals minus 10, the opposite of plus 10, or x equals plus 3, the opposite of minus 3, which is there. Okay? Right. Calculate the perimeter of square C. If I save me going back up, I'm a little bit guessing this. I think I remember the square C. You've got it in front of you, but I'm pretty confident the square C was x plus 4 on all the sides were x plus 4, right? Right, we've got two answers for x, though, from here. We've got x equals minus 1, or we've got x equals 7 divided by 2. Right, well, we can't use both. If you ever get a part C in one of these questions, ignore the negative answer. It doesn't make sense. So I think quite a lot of you would realize that half of 7 is 3.5. So each side of the square is 3.5 plus 4, which is 7.5. Okay, they are nasty. Now, chaps, if you want to have a go to solve these two for me, try solving x squared plus 9x plus 22. No, change that plus because it wouldn't make sense to minus. Not that they matters when you're going to equal 0. Solve it. Don't just factorize it. Go ahead and solve it. All right, and also have a go at 2x squared. Oh gosh, I'm really sorry. I'm going to give you the answer to this one, right? And then, but you try and do it. So I just go trying to work it out now. Minus x plus 13x minus 7. Try that. Right, try that. Again, equals 0. So this time you'd start with 2x. But there's that slightly more difficult method at the top. Okay? And your answers, if you get them, right, pause the video and have a go, but your answers would be x plus 11, x minus 2, giving you, for the solve bit, x equals minus 11 or x equals 2. And here, it's going to be 2x Well, actually, I'm going to give you the final answer, which is going to be 2x minus 1 in one of the brackets and x plus 7 in the other bracket. But you've got a lot of work to do to get from there to there. Giving you the answers, x equals 1/2 or x equals minus. So we did the one, like, if you see that sort of shape, the center is double the top. We did the bow and arrow. Oh gosh, that doesn't look like well, we make it look like a bow and arrow. A bow and arrow. What am I doing? A bow tie, you call it. So the two angles at the top on the circumference at the top are the same, and the two angles on the circumference at the bottom are the same. We looked at isosceles triangles within circles, right? We said if that was the center of the circle there, then we had to sort of look. I mean, it's dreadful, isn't it? And we did things like that. We also looked at the cyclic quadrilateral, where you've got a four-sided shape, and the opposite angles in the four-sided shape add up to 180. Okay, this is the A and A star one. The A and A star one is really tricky. Okay, it is really tricky. It's called the alternate segment theorem, right? What BDF? I'm just trying to work out which angle they want to. They want this one, don't they? Okay. Now, what I can see here, chaps, is I can see a bow tie. Okay, I can see a bow tie. So from that, I can glean that this is 70 degrees. That angle CDB, so from C down to D and then up to B, is 70 degrees. Yeah, I can see that because of this rule. Yeah, using that rule, that one there. Right? Okay, this is the dodgy rule. I'm going to go different color. Okay, the dodgy rule is this. Okay, that. Which angle are they asking me for here? Sorry. Oh, in terms of W. Ugh. Right, okay. Here's the dodgy rule. The dodgy rule is that if you come along a tangent, which is what this line outside the circle is, and you get to a point like this, and then you come back on yourself, you make an angle, right? That angle there is the same as the angle that is made by the triangle from that line. So that angle there is also W, and that is called, it's the only A star one of these, it's called the alternate segment theorem, right? But the angle we are talking about now in my final color, let's go to can I choose a different color? I don't know if I can I? Maybe I can, come on. Yeah, okay. You can see this. Sorry, I'm just getting a bit carried away with colors here. Let's try green, right? The angle they're actually asking me for is this one, right? Okay. But there's a straight line here. So to find the green one in terms of W, it would be 180, take away the 70, which is this one here, take away W, right? And then that would leave me with that, if they add up to 180, or 110 take away W, right? That is, no wonder that's A star, okay? I just want to remind you what that alternate segment theory is, just in case they give you hopefully an easier version. Now, what I'm actually saying is this. If you have a circle, oh my goodness me, and a tangent to the circle, if from the tangent you come back on yourself so that you make an angle, if you from that line, you use that line as one side of a triangle, weirdly, that angle there is the same as that one there. But it's the same from the other direction. If you come from this direction and back on yourself, so you make an angle this way, that angle there is the same as that one there. And that is called the alternate segment theorem. So close, right? A little bit sniffy here, got a cold. Chaps, I don't want to go into surds for a minute. It's on my. I'm going to direct you to other videos in a minute. Okay, and there's plenty of surd questions in my other video, which you can rely on. As there are this. Okay, trig graphs. Again, we'll rely on the other video. In fact, chaps, do you know what? I'm going to bring this to an end. What I'm going to say is this, if you've watched this one first. I said I would create a video called Multiplication Maniac United or something like that, right? What I've done instead is created a playlist called that. That playlist will have this video in it, which has got a few extra questions from today, right? But more importantly, it's got two other videos. One is a C-B grade, video 1 questions, mixed, watch it if that's where your aim is, okay? The other video in this playlist, Multiplication Maniac, is lots and lots of A and A star variation of the questions. I think they're both about half an hour. So if you've watched this and you think you can dedicate another hour to tonight's revision, that's the plan. The 3 videos in this playlist, Multiplication Maniacs. Good luck for tomorrow. Let me know how that goes.